Hey guys, Mr. Jenkins here for your, let's see, this will be your 7th and final lesson for Chapter 2. It is called Section 2.8, Proportions and Similar Figures, or Applications of Proportions, etc. It goes right along with what we've been doing in 2.7 and also the DMR, so you should have a head start somewhat. As you can see, our learning target is I can find missing lengths in similar figures. I can use similar figures when measuring indirectly. So similar figures have the, sorry about that, similar figures have the same shape, but not necessarily the same size. Okay, so same shape in math means the exact same angle measures. Okay, I kind of think of like if you are working with a photo in like Microsoft Word or Google Docs or something, and you drag the corner of it to enlarge it, that kind of makes a similar figure. It keeps that same proportional size, but can make it larger or smaller. So looking at this first example, this is just kind of some definitional type stuff. One thing that's important is this looks like the kind of the top part of a rounding sign, like approximately equal to, but anyways, that means similar to. Triangle ABC is similar to FGH. And I can tell that because if I put corresponding sides together in a ratio, then I'll see that they are all equal. In other words, if I put AB over GF, that's going to be equal to, if I put AC over FH, and that's going to be equal to, if I did BC over GH. Okay, those are all equal fractions. They're all equal to 2/3. Another way that I can tell that they're equal is just by using my calculator. So if I did 8 divided by 12 to turn that into a decimal, I see that it's 0.6 repeating. So is 10 divided by 15. And so is 12 divided by 18. So that shows us that those are in fact equal, stating that we're proportional here. So that shows that these figures are similar. All right, so example 1 says finding the length of a side. This is a multiple choice question right out of your textbook. It gives us the length of AB, it gives us the length of BC, and then let's see, what's it want us to find? It says, what's the length of DE? So we have to use what they give us in order to find the length of DE. And that's the distance from point D to point E. So I'm going to put a variable there. We'll just call it X, just to show that that is what we're finding. Okay, so there's lots of ways you could set this up. All right, so one strategy would be kind of use, I'm trying to think of the best way to show this. Well, let's set it up like we did up there. Okay, so let's put two corresponding sides together. So let's put AB with DE. You can tell that those correspond to each other. So let's say 10 over X is equal to. Now, here's a key thing, right? I wouldn't want to do AC and DF because I don't know AC, right? So the only other thing that makes sense to do would be to use BC with EF because we know both of those quantities. So 16 over 12. And again, think back to our DMR. Would it be right if I would have done 12 over 16? The answer to that is no. It would not be correct. Okay, so now we want to go ahead and use cross products to solve. So just kind of quickly, we get 16x equals 120 because 10 times 12 is 120. So just 1, 2, 0 divided by 16 is going to give me 7.5. Hopefully we see 7.5 as an answer choice. And it looks like we do. So that's always good news. Circle that or bubble it in, either way. All right, so moving on. This is a common type of problem here you might see on a state test or some kind of similar test. It says the sun's rays strike the building and the girl at the same angle. That makes it understood that this is going to be a similar figure, forming the two similar triangles shown. How tall is the building, right? So they've already put a variable on what we're trying to find, right? This would be the height of the building, the side of the triangle, if you will. Okay, so we're going to try to set up a proportion. Okay, so let's put the two sides that we know kind of together. So let's put the length of the shadow of the building with the length of the shadow of the lady there. So we can do 15 over 3 or 3 over 15. It does not matter. Okay, but since I did 15 over 3, then that means that my other fraction is going to be x over 5 instead of 5 over x. Okay, because here I did building over, building shadow over woman shadow. So now I got to do building height over woman's height. All right, and then we just solve. That's the easy part. So 3 times x is 3x. 5 times 15 is 75. And then 75 divided by 3 is going to give me x equals 25. X equals 25. That's correct, yeah. And then we want to put it in context, so notice that's all in feet. So final answer would be 25 feet. And then just context, right? Does my answer make sense? You know, the woman is taller than her shadow, so our number should be bigger than 15, and it is. Okay, and then at the end of the day, 5 over 3 is the same fraction as 25 over 15. Lots of ways to check. All right, then it says a man who is 6 feet tall standing next to a man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet, and the shadow of the flagpole is 17.5 feet. What's the height of the flagpole? Okay, so I'm going to do this without a diagram, but I would say if you struggle to organize your thoughts here, sketch that out, right? So you have, you got a man and a shadow. You've got a flagpole. And its shadow, right? And then you can use that diagram to kind of put stuff together. Okay, I'm just going to use the words. All right, so let's see. So the shadow of the man is 3.5 feet. Shadow of the flagpole is 17.5 feet. So these correspond to each other because they're both shadows. And I'm going to do 3.5 over 17.5 just because that was the order they were listed in. I could easily set it up the other way. The only other real quantity they give me is that the man is 6 foot tall, right? So 6 is either going to go here. It's either going to go in my numerator or denominator. So I want it to go in my numerator because 3.5 feet goes with the man. Okay, this is the 6 is the height of the man. 3.5 feet is the height or the length of the man's shadow. Okay, And then it says, what is the height of the flagpole? So it would make sense that the variable would go here, because this is the shadow of the flagpole, so this should be the height of the flagpole. All right, so let's see. Start to solve. We get 3.5x equals whatever 6 times 17.5 is. Looks like 105. So then we'll go ahead and just divide that 105 by 3.5. And we get 30. All right, so 30 is equal to x. Remember what we're finding here. That is the height of the flagpole. So it looks like everything's in feet. So 30 feet. Now, the thing that's kind of cool about this lesson, but also the thing that can make it confusing, is the way that I'm setting up these proportions is not the only way to set them up. There's lots of ways you could do it. If another way makes more sense to you, then do that. If this video doesn't help, look at the notes. I set them up different ways on the notes. So anyways, just find what works for you. That's the biggest thing at the end of the day. And as you can see, as always, your assignment is the Math Excel. So this is the last lesson. So hopefully you don't have a whole lot of catch up to do, because I think everything is due by tomorrow at midnight. So anyways, that concludes our instruction for chapter 2. And then we will get into the end of the chapter project starting probably tomorrow. So that concludes our lesson. Hopefully this is helpful. And thanks for your time.